Hello friends, welcome back to my channel once again. This is a man Alam, and today we are going to learn Circle Theorem or plane geometry 2. Now let's take a starter. The circle to the right with center O has a diameter of 20 centimeters and the perimeter of the triangle OAB is 36 centimeters. Now calculate the area of the triangle. So this is a very nice question. So we need to find the area, and the area of the triangle AOB is half base times height. The diameter is twice of the radius. So therefore, the radius, to get the radius OA, we have to divide the diameter to 2. That is, the diameter in the question is 20 centimeters. So when I divide 20 centimeters by 2, you have 10 as your radius. So it means that line OA is 10 centimeters, which is equal to line OB. So OA is equal to OB, which is equal to 10 centimeters. Now we have to get AB because the formula is half base times height, and the base is AB. Now how do we get AB? Because they said the whole perimeter of the triangle is 36. So it means that I know OA, I know OB, which is 20 centimeters. When I add 10 plus 10, that's 20 centimeters. Now I subtract it from 336, which is the total circumference, the total perimeter. So I'll get only AB, which is 16. Now to get the height of the triangle, we need to apply the Pythagoras theorem, which states that the square of the hypotenuse is equal to the sum of the two opposite sides. Now when we take it the square root of both sides, that is, get OA squared, then the half of AB, which is from here to the middle, and I get that one to the squared, and your height is 6 centimeters. Okay, now after that we have gotten the height 6 centimeters, and now we know our line AB to also be 16 centimeters. We can now solve for the area of the whole triangle OAB. Now we just multiply it half times 16 times 6 centimeters, which is going to be equal to 48 centimeters square. Feel free to pause the video and try it on your own and see whether you can get it. Now these are live application of what we are going to look at. You can see the orange here is more like a circle with lines on inside forming angles, and then we can see a wheel here, that's a bicycle wheel, forming an angles. So you can see an angle here, you can see an angle over there, and then we apply it in the real life. Now by the end of this lesson, you should be able to discover that angles, a chord or an arc subtend at the circumference of a circle in the same segment are equal. You should be able to discover that angles, a chord or an arc subtend at the center of a circle is twice the angle it subtends at the circumference. And now we should be able to solve at least 3 questions using the theorem of the circles that we have learned. Now today, once again, we want to look at angles within a circle. And so far we'll learn about angles in a semicircle. We also learn about angles at the edge and center of a circle. Now let's define our circle. Let's know the various dimensions of the circle. So we have the radius, which is half the diameter, and then we have the diameter, which is the line AB over here. OA is the radius. Then the center O is the center, and then we have DE, which is a chord, and then a segment is the part shaded. You can also have a sector, which is in the second diagram. FOG is a sector. Now with this, let's look at the first theorem. The angle in a semicircle is always 90 degrees. Example, when you have this, it's forming an angle from the diameter to the circumference of the circle. So it's a semicircle, that is if you take it from the diameter, and it's always 90 degrees. Another example can be like this, it's 90 degrees. So far as it is taken from half of the circle, it is always 90 degrees. Another example is over there. Alright, so it means that when I take, if here is 90 degrees, it means the sum of x and y should also be 90 degrees, because the complete triangle, the sum of its interior angles should be 180. So if the angle subtended at the circumference is 90 degrees, then the sum of the other side should also give me 90 degrees. That is why we have x plus y here should give me 90 degrees. Alright. Now let's try our first example. Question 1. Since that line AB is the diameter of a circle, angle CAB is 50 degrees. Angle CAB is 50 degrees. And so we should calculate x and y. Now, x is subtended at the circle, so we should know what it is. It's 90 degrees. Your angles in the semicircles give you 90 degrees. Or angles subtend from the diameter of a circle to the circumference of the circle forms 90 degrees. Then let's look for y. Y is now the sum of 50 plus 90 and taking it out of 180, because in the whole circle, the triangle, it should give us 180 degrees. So if I know my 90 and I know 50, so I sum them and I get 140. And 140 from 180 is 40 degrees. So y is 40 degrees. Now the next example, line XY, as seen here, line XY is the diameter of this particular circle. What is the sum of angles A and B? Then we'll explain our result. So sum of A and B, we know it should give us 90. So we know we have looked at this theorem, it should give us 90. And so C will also be 90. Okay. Note, so we have this as simple as that. Now, the angle in the semicircle is always 90 degrees, as we have looked. Let's look at the proof over here. Now, the circle has a triangle drawn inside it, where the circle has been split into two. So the diameter split the circle into two, forming two separate semicircles. Now, imagine we draw a line from the point of the triangle to the center, in effect the radius. So that is what we mean. You see that it becomes a radius. We have another radius over here. So these two lines, since they are all radius, they should be equal, because the radius is always equal. Now the smaller triangle created is an isosceles triangle, because the two sides are the radius and they must be what? Equal. And then if we label the equal angles as x and then x, it means that the other angle formed over here is 180 minus the sum of x and x, which is 2x. So we have 180 minus 2x to get this small place. Alright, because you know that in the sum inside here should give you 180. So if I know this and that 2x, then I get the other one. Now so this is a theorem which we have just proven. Now to work out the other angles on the straight line, you would do 180 minus 2x. So it means that now that I know 180 minus 2x, and then I want to find this side. You know, angles on a straight line sum as 180. So we take this angle from 180 to get this angle. That is what we are seeing by saying that what 180 minus 180 minus 2x, and then you get your final answer. So it means that this angle here is equal to 2x, which is confirming a theorem that two opposite interior angle is equal to one exterior angle. So you see that 2x plus x 2x, which is equal to 2x over here, as seen in the explanation. Now apply the same logic to the other triangle using y instead. So we'll give the other central angle as 2y. So we got yy over here. So the sum of two opposite interior angles is going to give you one exterior angle. So here would also be 2y. So 2y plus 2y must give me 180 degrees. That's angle on the straight line. So x plus y is equal to 90 degrees. Hope that is okay. Now the next example, work out all the missing angles. So we got to know the side. Now that we know here is 50 degrees, and this is a diameter, this is a radius, and this is also a radius. So we should know A to also be what? 50 degrees. You can try it out. And that's 50 degrees because it's an isosceles triangle formed by COB. Then angle B should also be the sum of 50 and the 50, this 50 and this 50. Out of 180 we get B. So 180 degree is the sum of the angles in the triangle. So now that we know 50 plus 50 is 100, then taking it out of 180 we get B to be 80. Now we get B to be 80, we can know C by taking it out of 180 also. So my C is also equal to 100, because when I take 80 out of 180, because angles on the straight lines form at 180, so take 180 minus 80, you get C, or the sum of two opposite interior angles is equal to one exterior angle. So 50 plus 50 is giving 100, just as it is over there. Now I know my 100, so you should know D, which is 40, is also be 40, because it's an isosceles triangle and then they are equal. Next example 4. Work out the two labeled angles and state reasons for your answers. Feel free to pause the video and then try it and come back to the video. But then we know that angles on a straight line is summing up to 180 degrees. So if I know this to be 72 degrees, then I'll take it out of 180, then I'll get x. So my x is 108. Now let's find t. Now that I know x to be 108, but the triangle OAB is an isosceles triangle, which means that the base angles are equal. This angle here and this angle are equal. So I take the sum of them plus 108 out of 180, and you are going to get your final answer as 36 degrees, as seen over there. Now theorem 2 states that opposite angles in a circle or a quadrilateral is supplementary. Now we say that when you sum up these two opposite angles, it should give you 180 degrees. When I sum up this, it should also give me 180 degrees. When I sum up x and y, it should give me 180 degrees, because they are opposite angles. Alright, so opposite angles in a cyclic quadrilateral add up to 180 degrees, and we're going to get the proof over there. So imagine we join two corners to the center of the circle, just like that. Now if we label the top angle as x, and then the number at the center will be doubled that of the x. Now do the same thing with the opposite angle, labeling it y first, and then the one at the center will therefore be 2y. Yes, and then 2x plus 2y must give me 360, because angle in the complete circle must give me 360. So 2x plus 2y must give me 360. Therefore, x plus y is equal to 180. You see the proof there. So x plus y must equal to 180 degree. Now the angle at the circumference is half the angle at the center. This angle is half that of 50. So we get 50 multiplying 2, you get 100. So it means that the angle formed at the circumference is half the angle formed at the center. So anywhere part of the circumference is still the same. Okay, so 15, it means the angle formed at the center will be 30. Anywhere part of the circle is the same procedure. And then when we sum the two opposite angles, 115 plus 65 to give me 180. That is what we should know. And the angle here is half of 130, and 130 is twice of 65. That's the opposite, all of them. Now it says that this angle here is twice a. So to get a, I divide this 122 by 2. But we know this angle and then this angle must be the same, because they are all subtended at the circumference from the same chord. So a is 61. Angle at the edge is half the angle at the center. Now b is supposed to be 61, because same as the above, the angle has just moved right edge and a bit small, so it's the same thing. Let's work out angle P and Q and explain how we got the answer. O is the center of the circle, and then ABC is a cyclic quadrilateral. Let's find Q and then that of P. We know P is half 102, so we can get P, and then P plus Q to give me 180. With this logic, let's continue. So it means that 102 divided 2, we get P to be 51. Now 51 plus 9 Q to give me 180. So therefore, to get Q, I take 51 from 180, and then Q is 129 degrees. Now the angles at the circumference is half the angle at the center. So imagine we split the diagram down the middle. We split something like this, and then we can label the angle in the isosceles triangle to the left as that XX. So it means that to get the one in the middle, I got to take it from 180. So we get 2x from 180. Now we find again that the angle beneath will be 2x. Okay, because they must sum up to 180 degree. Apply the same idea to the other triangle using y instead. So we also see that it's also 2y. Now with this logic, it means that y plus x is half of 2x plus 2y. Is that not it? So it means that the formula is very correct. X plus y is twice, so it's half of 2x plus 2y, and we sum them. Now theorem 3 is still continuing. Now the angle between a tangent, which is here, the line touching the circle is a tangent, and a chord, and the chord is a chord. Drawn from the point of contact is equal to the angle in the same segment. So what we mean here is this beta angle here is equal to the alpha angle over here. So look at the theorem very well. Let's pick an example. So it means that x will be equal to what? 43 degrees, just as we have seen it over there. Look at the theorem. The two tangents drawn from an external point to a circle are of the same length. So they are all tangents. So this tangent is another tangent, and since they are drawn from the same length or with the same length, this side is 90 and this side also be 90, and they have the same angles. So it means that if here is 38, here should be xx as seen. Now the diagram below shows 4 points A, B, and C on the circumference of a circle. BD is a diameter. Let's try to get this. So this is your work. Try it and come back and check the result. Farewell. If you like this video, don't forget to subscribe to the channel, hit the notification button so that you'll not be left out when I release any other video. More to the point, comment below so that I can improve upon my tuition. So you can quickly apply the theorems here to get the value of x. We know this side will be 90, this side also be 90. If here is 90, I can get this angle over here. And if I get this angle over here, I can get the 70. So if I get the 70, then I'll be able to get the other side of the value, which is x, because this is bisecting the b into 2. So here 70, here should be 70. The sum of this and this will give me 180. Alright, that is very fine. So the value of x is 70. Now this another one, you can also work it out, the value of x, then we are good to go. Thank you very much. Have a nice day. These are all work for you.